Okay, welcome back everybody. So now in this video we're going to do some examples involving the hypothesis testing of claims about differences between means when you're using with dependent samples. So in this first example we have a claim that says mu sub d is negative, and we want to test this claim with a level of significance of 0.05. So the sample statistic, let's say we've done the sample statistics, and this D should be actually D bar, but okay. In this case, D bar, we took a sample of size 14. The average of the differences was negative 1.7, and the sample standard deviation was 3.2. Okay, so let's first, we'll assume that the population is normally distributed, and go from there. This is the strict inequality, so this has to be the alternative hypothesis. Okay, so that means the null hypothesis is the opposite of that. It's greater than or equal to 0. And we know that this is the claim. Okay, so that means unusual values of D bar would be negative. So we're using a left-tailed test, okay, and where we have, this is the t-distribution with 13 degrees of freedom, okay, and this is alpha, this is 0.05. Okay, so then what we do is we go to our t-distribution. We look up under 13 degrees of freedom, one tail, where alpha is 0.05, and we get that this is negative 1.771. Okay, this is from our t-tables. Then we compute the value of little t, which remember is d bar minus mu sub d over s sub d over square root of n. And this is, so this is negative 1.7. Now what's mu sub d? We're assuming mu sub d is greater than or equal to 0, which means that we're assuming the possibility that it could be equal to 0. So we're just going to assume that this is equal to 0. Okay. If it's actually greater than 0, it's not going to affect our decision. Okay. And then s sub d, we said, is 3.2, and the sample size is 14, so this is square root 14. And when you do that on your calculator, what I like to just do is, I would say negative 1.7, divide by 3.2, and then multiply by the square root of 14. And this turns out to be negative 1.98. Okay, which is just inside of the rejection region. So that's why we reject H0. And so we say there's, okay, we're rejecting H0, so there's enough evidence to support the claim. Let's look at another example. In this example, the claim has equality in it. It says mu sub d is equal to 0, and we want to test this with a level of significance of 0.01. And the sample statistics, once again, my mistake, it should be d bar, is 3.2, s sub d is 8.45, and the sample size is 8. Okay, once again, we'll assume that the sample is random and the population is normally distributed. So we can proceed. Our claim has equality in it, so it's the null hypothesis. So our alternative hypothesis says mu sub d is not equal to 0. And the null hypothesis is the claim this time. We're going to be we're assuming this to be true, so it could be that unlikely values of d bar could be positive or negative. So this is a two-tailed test. And the degrees of freedom is 7, one less than 8. Okay? Alright. So, let that ring. So then next we have that, hang on one second. Okay, thank you for waiting. Now we're using the level of significance is 0.01. So this is half of that. This would be 0.005. Actually, you don't really even have to do that. The thing is, you just look at the table for for two tails where alpha is 0.01, and you get that this is the value is 3.499, and this would be negative 3.499 for two tails. And we compute the value of t. This is once again, this is d bar. This is 3.2 minus 0 over 8.45 over the square root of 8. Okay, and that turns out to be 1.07, which is in here, which is not in the rejection region. That's not even close. So that we don't reject H0. Right? And then we have, so there's not enough evidence to, the claim was the null hypothesis, so we were either going to reject it or not reject it, and we're not rejecting it. So there's not enough evidence to reject the claim. Okay. Let's do one more example where we have a lot of data to go through. So in this case, we have an instructor for an SAT prep course claims that the course improves test scores of students, and the SAT scores of 10 students that took the course are given below. At alpha equals 0.01, is there enough evidence to support the claim? And then we have all these. We have these columns and the numbers of the students' names, or the number corresponding to the students' names, and their scores before or after the course. And okay, so in this case, this is different from the other examples, as we have to actually compute what S sub d and d bar is. Okay. So what we do is we have to use our calculator. And so here it is. See that? We go to edit, and you can see what I've done here. In L1, I've entered all the scores that are before the prep course, and L2 is all the scores that are after the prep course. So these are just the columns I gave you that are given in the example. In L3, what we've done, let me just show you how we compute this. We really want to take the difference L1 minus L2. So where it prompts us for L3, I'm going to, when you go up here to L3, select that, and then enter L1 minus L2. Okay, and then hit enter, and here you get all the differences. Okay, now these are the ones that we want to find the mean and the standard deviation for. So we go, once we then go to stat, we want to calculate this time. Choose first variable stats, choose L3, and it tells you the mean. Now remember, it says x, but we want d bar, but d bar is x bar. It's the mean of these values, so it's negative 50. So x bar is negative 59, or d bar is negative 59. And the sample standard deviation, remember that is Sx. That's 19.119. I'll just say that. Okay, so all right. And n is 10, of course. All right, now, what is the claim? Okay, well, if this actually works, we know that these numbers should be bigger than these numbers, which means that the average difference of this number minus this number should be negative. So in terms of mathematically, the claim is actually saying that u sub d is strictly negative. Okay, that's our claim. And so our null hypothesis is going to be the opposite of that. So once again, that's a claim. And once again, we're going to be using a left-tailed test. Okay. In this case, the alpha of significance, the level of significance is 0.01. The degrees of freedom would be 9 in this case. And so we go ahead and we look up the 9th degrees of freedom, where alpha is 0.01 with one tail, and this number turns out to be negative 2.821. Okay. All right, so now we go ahead and compute t. That'll be negative 59 minus 0 over 19.119. That's from up here. And our sample size is 9, so this is the square root of, sample size is 10, so we take the square root of 10 here. And this is going to be a very large negative number, negative 9.758. Okay, that's all we need. It's clearly way, way, way into this rejection region here, right? So we can reject H0, support the claim, and so there's enough evidence to support the claim that the prep course works. Okay? So in some of these examples, you actually enter these numbers into your calculator, compute the differences, okay, and then take the average of those differences. So get some practice on the homework, and I'll see you next time.